Hello, hello, and welcome to the Hive series on PCB design with KiCAD, or should I say welcome back. My name is Ben, and in this series we've been walking through the PCB design process using KiCAD as our electronics design software. Previous videos, that's parts 0 through part 5C, went all the way through the design process, resulting in a completed PCB ready for fabrication. One thing I mentioned during that design, or during that process, and was featured on the original EDA design flow in part 2, was that library management and the idea of using only project scope libraries. But when we actually did the design, I ignored this for simplicity and time constraints. In this video, I will walk you through library selection and generation of a single project scoped symbol library to package with the rest of your project and keep your work insulated from external changes. This material is of course not required for a functional design, but it is good design practice for KiCAD at least to keep your parts all protected in a project level library. But because this is not directly related to the design flow of the previous videos, I'll make no assumptions of the state of your system or knowledge, so I apologize if some of this is repetition for you. But otherwise, let's get started. So after creating the project, typically the first thing you would want to do is create that single library where all of your components will live. You'd have one for symbols and one for footprints. This would be a living library, as in the components added to this library throughout the design iterations would change and adjust, but try not to remove any components that you never know exactly what you're going to need again. We'll start by making the symbol library, as I mentioned, and you can click the symbol editor icon on the right to open that window. So this is the symbol editor window. If you're familiar with this, the next few slides will be a bit of a review. On the left, we've got all our currently available libraries. Library availability will be discussed later. So first, we're going to go ahead and make a new symbol library. If you've already gone through under File New, a new library, excuse me. If you've already gone through the design process in the previous videos, you don't have to make a new library. We're just going to be using the flashlight circuit that we developed there. If that makes no sense to you, don't worry about it. Select project for the scope here, because again, we want to minimize the use of global libraries in our project, so we want to have that project scope. I personally like to name my project-specific libraries with the same name as the project and in the same folder. So we've got a new empty library on the left there. And again, if you've previously made this library, you can move forward with whatever library you made there. So what we want to do here is we want to be copying any symbols that we'll need that are available from the global built-in libraries into our new project-specific library. That way we insulate them from any changes because we're copying them, so any future changes won't be affected, and we can just zip that file together. We've got all the components we need in that single library. So which symbols do we need? If you have not seen this before, here you go. And if you have seen this before, this is a nice little review of what we need. Don't worry, I will walk through each of these steps and remind you to copy these in as we go along. It's always good practice to start the ones that have standard symbols, so not the generic box in the middle. Many standard symbols, as we've discussed before, can be found in the device library. Otherwise, others like switches in particular have their own libraries. So let's locate the device library first on the left. Symbols in many libraries are named relatively intuitively. So what do we think the library for a capacitor might be called? Do you see that part? It's right there. And if you click on it, you will get, or double click on it, you will open the symbol. It's always good to double check the symbol is what you expect it to be. This does look like a capacitor, so I think we're good on that. So to copy the symbol, we're going to right click on it in the libraries pane specifically to open the context menu, and then you're going to go ahead and click copy. Or you can just highlight it and press Control C. Note that duplicate will make a copy in the currently selected library, but since built-in libraries are read-only, that won't really work for our purposes. So it actually has to be a copy-paste this time. Now, we're going to go and right-click on the library that we want to paste the symbol into and click Paste Symbol. Control V or just regular paste won't work on symbols. We really need to do the paste symbol option. Ta-da! And a copy of C has now been, the capacitor symbol has now been added to our custom library. Note the asterisk next to the symbol in the library. That just means it hasn't been saved. So Control S to save. I would save every time you add a part, I would save. It's always annoying to have to redo work, especially tedious busy work. Next, go back to the device library and copy the inductor into your new library. What do you think that is called? If you guessed L, you guessed correctly. Congratulations. If you're not an electrical engineer or didn't know that, then you can find the L symbol in devices and just copy that in the same way we copied the C. Next is the resistor. If you scroll back to the device library and locate R, you'll find something that looks like this. Now, if you're an electrical engineer, this might not quite be what you expected, although if you aren't an electrical engineer, then maybe you have no idea. But there are actually two standards for electrical symbols, the European IEC standard and the American US ANSI standard, because of course, this happens to be the IEC standard for resistor. In American nomenclature, this would be an unknown impedance symbol. The ANSI symbol that you might be more familiar with is actually called R_US. Copy whichever one you'd like or both into the new library, totally acceptable, and both are understood, especially when they have a little R as their name next to them. Great. So next we're going to go look in the device library for the diode. Any idea what it might be called? If you guessed D, you're partway there. D is actually just the regular diode, but all diode type symbols start with a D as well. So remember, we need a Schottky diode in particular. It's the one with that little like curvy, basically it has serifs on the line, on that little vertical line. Cleverly, and very originally, it's called D_Schottky. There are multiple varieties depending on pin count and if your diode is special. Ours isn't. That depends on the part you actually chose. So double check the part you chose. But I'm telling you that the one I selected is not. So you can go ahead and copy it over. I personally prefer the filled version here instead of just D_Schottky because I think it looks nicer, but they are completely functionally identical. Next up, the battery. Remember that the battery holder is the actual part that we're placing on the PCB, but that we want to symbolize that it's a battery. So we're going to use the battery symbol. So let's go ahead and find the battery symbol in device. So no, we don't want actually just battery because that's a multi-cell battery. Functionally, it would still work because, again, the schematic is all about reading things. So it gives us the readers the wrong impression that somehow a multi-cell battery is critical to the operation of this, where it's not. We want battery cell, which is the single cell battery. Looks like this, so copy this guy into your local library as well. If you're coming from the design videos, you might recall the pin type issue we had to resolve. It's easy to resolve at this point by just editing the project scope library version of the symbol within this window. But the last one from devices, we're going to go find the LED. Again, under devices, you can search for LED. There's a whole bunch of different options that are 2 pins just like this. I prefer the filled option myself, but a variety of them. Any 2-pin option will work here. Great. So now your library should have 6 of the 8 symbols that we'll need for the circuit. The 7th is going to be the switch. Unlike the last few, switches are not found in the devices library, but rather in the switch library, as if you've watched the earlier videos, you would know. So which switch do we need? We're actually looking for the SPST switch. So you're going to add that to the library. And if you don't remember the terminology, the SPST is going to stands for the single pole, single throw switch, which means it controls a single circuit or one pathway with one output that is either connected or disconnected. If you've already generated this symbol for the IC during the design videos, congratulations. You can skip basically to the end of this video. I'm going to show briefly at the end how to manage which libraries are available. I'm not sure exactly when it's going to be at this point, so I apologize for not being more specific. For the rest of you, the last component is going to be that IC, that integrated circuit, that chip. ICs have slightly different components that we have to put down, or slightly different than the other components we have to put down for 2 reasons. The first is that the symbol is relatively unique, is pseudo-unique. It's going to be difficult. It has a specific pin function or name to number mapping that needs to be accounted for, and finding another symbol that has exactly the same pin to name mapping is going to be difficult, to say the least, especially like hunting through all of these symbols. So we don't really want to do that. And the footprint also may or may not be in the libraries. It's a standard package, so probably it is, but we don't really know that at this point, right? So the first thing to check is if it is in one of these built-in libraries. Like maybe that's, and we're only looking at the symbol right now, but let's say it is. That would be great, right? We can use the filter at the top left to search for the RT4526, which is the part that we're looking for, but you'd find that it was not. This is pretty normal for most ICs and non-standard parts because, as I mentioned before, they're kind of pseudo-unique, so you don't have that. The next option is going to be to see if someone else has already done the work of generating that symbol and footprint, or footprint. Sometimes you can find these on the supplier's website, like this part. Unfortunately, the RT4526 does not have such a link. Sad. We can locate something or try to locate something for the IC online. There are plenty of places that do this. The two that I've used are Ultra Librarian and SnapMagic, which until recently, like the end of 2023, was called SnapEDA. Ultra Librarian doesn't require an account to download models, but it does require one to request models. SnapMagic, in contrast, requires an account to download or request models, but or both. But you can also generate browser symbols in browser for certain components, as well as footprints. Actually, lots of footprints there. Both accounts are totally free to open. Nothing wrong with that. So opening an account on both, having that availability is definitely really nice. Let's start with the Ultra Librarian homepage. That's what this looks like. Big search box in the middle. Let's search for our part. Unfortunately, we see that the part is grayed out here, so it doesn't. They don't have any models for it, and you can also see that on the right-hand side where all of the little things are not filled in or not red. They're gray. So if we click on the part, though, we get to the part page where we can actually request parts. Make sure you're logged in before you do this, otherwise you won't be able to request anything. You can request either a symbol or a footprint. They'll actually return both to you because both are made at the same time. So this is what the request part looks like, and you just submit the request, and then it tells you they'll get back to you within 48 hours, which is standard turnaround time. So that may or may not be too long for you. I don't know your design constraints at this point. But we can also check SnapMagic. So SnapMagic looks like this. They've got their InstaBuild symbol and footprint generator up on the right there. Unfortunately, the symboled portion is actually only available for certain footprints, and that'll be identified on the parts page, not in here. But the footprint generator is reasonably nice. So that's good to know about, at least. If we search for the RT4526, we will get this page. Be careful because the first part actually isn't correct. That's not the right part that we need. We need the bottom part here, but unfortunately still no. We've still got these unfilled icons, which means the models aren't available. The filled icon there is only for the datasheet. So similar to Ultra Librarian, getting into the parts page, we can request directly from the page. Sometimes that's where the InstaBuild link would be if they had one. Once you request, that's great, but they have no guarantee on return times here, which is a little unfortunate. C'est la vie. You do get a cool ghost, though, when you request, so that's kind of nice. So we struck out 3 times. What did we do? So first, we could keep searching randomly on the internet for another part, but returns are definitely diminishing, and also the quality is definitely not guaranteed. So instead, what we're going to do is make the symbol in KiCAD directly. Symbols are relatively easy to make, and they're less prone to errors than custom footprints are, but they can be tedious with many pins. It's totally doable to make them without waiting for Ultra Librarian or SnapMagic, especially if they're only like 6 pins like this one is. Once you get good at it, this is like a breeze to do. The real problem is like microcontrollers with 100 pins. Those suck. So if we did find a model, we could import it directly into our library here. You would go to your library, you'd right-click on it and go to Import Symbol, and then you would import the KiCAD_sim file that you downloaded from the website, which may be in a zip file, and you'd unzip it, obviously. But once you confirm the pins and the sizing and whatever else you'd like to confirm, because again, this is your opportunity to do so, not the only opportunity, but a good one. You can then save it, and it'll be automatically added to your library and available for use, which is really nice. But since we haven't found it, let's go back to. So we can create a new symbol just by hitting the N key, and it won't necessarily create it in any specific library at this point because when you save it, it'll ask you to add to a library. So you can just hit N, or you go to File, New Symbol, or hit the icon on the upper left there. A couple different ways. And you'd fill in the pop-up window here. For ICs, I give the symbol name the full part number. Generally, good policy is name the symbol with the part number, which in this case would be the RT4526. You can leave the JG6 off in this case, because if you read the data sheet, those are actually the only options for those final 3 digits, and they're mostly package specific, so it doesn't really matter. If you're deriving a symbol from a different symbol, meaning you're like copying another symbol and then kind of adjusting it, you would add that in here, like maybe a polarized capacitor from a basic capacitor, or you don't like how many squiggles there are in a resistor or something like that. And the last thing we're going to adjust is the reference designator. That's the letter that KiCAD uses to identify all instances of this symbol. Each instance will get a number, so a resistor might be designated R5 for the 5th resistor in a schematic. U is very common for ICs, though you could definitely choose something else if you wanted to, and it's fine for multiple symbols to have the same designated character, like U or R, because it just means that they're of the same type, so to speak, or at least they'll be considered of the same type. The rest really doesn't matter, so you can just go ahead and click OK once you've filled those in, and you end up with a window that has a giant U in it, where which is the reference designator. Let's just zoom out here. The U is placed at the anchor point, which is the symbol at which the symbol would be, which is the point at which the symbol will be attached to the mouse. So we're going to move both of those later. The U here will be the reference designator that we defined previously and unnumbered until it's in the schematic. So as usual, grid spacing and units are defined on the left. Make sure to check the grid by right-clicking. It should read 50 mils or 1.27 millimeters, or else KiCAD will be very sad later when you can't attach any wires to it, because the wiring in a schematic only works on a 50 mil grid. I usually select mils for my unit because I'm used to thinking of hole sizes and trace widths in mils, and because I'm used to imperial units, but you can readily use metric units as well. KiCAD is based on metric units, so you'll get some cleaner numbers if you care. Note that mils and millimeters are not the same if you didn't know. Mils or thou are 1,000th of an inch, that's 0.001 inches, whereas millimeters are the metric unit. It's 1,000th of a meter, 0.001 meters. Roughly, you're going to get 1 millimeter is 40 mils, or 1 mil to a roughly 0.025 millimeters, give or take. First thing I like to do always is make all my pins. So how many pins do we need, and what are they called? Let's go to the data sheet. This is what the data sheet looks like. It's page 1. We're looking for anything that ties pin numbers to functions, or actually more likely pin numbers to names. Usually it's a table. It's not here on page 1, but it is conveniently located on page 2. The physical location isn't relevant yet. We only really need the number and the name. So back in KiCAD, we're going to add a new pin. The icon is on the right at the top, or you can hit the A key. Bunch of options in here. We're going to start with the name and number. If you've forgotten what those are, it might be obvious at this point that having 2 screens is very helpful, or you can be a wizard with Alt-Tab. I think for Apple, it's Apple Tab, or the Apple key tab, Command Tab. We're going to start with pin 1, which has a name of LX based on the functional pin description table I've copy-pasted on the right. The electrical type is the only thing that's a little bit tricky. By default, it's set to an input, but is it actually an input? Let's go back to the pinout table. So the pinout table reads for pin 1 that it's a switch node, open drain output of the internal N MOSFET, connect this pin to an external inductor and diode. Those are words. I know what they mean, but also that doesn't tell me what electrical type it is. Sort of an open collector, but I'm a little concerned about choosing that. I don't know what it really means. Does that limit me in some way? No idea. If you're not sure what it is, or you want to be get the most broad, least problematic potentially pin electrical types, you're going to want to set it to either bidirectional, unspecified, or passive. Passive in particular is the most common one in most of the built-in libraries, so take that for what it's worth. The design actually won't, or the type won't actually cause the design to fail in any way, but it might cause you headaches with the ERC later if you're not, even if you are careful, because technically each pin type is only allowed to connect to a subset of other pin types. Otherwise, the ERC will throw an error. So it's kind of up to you. I chose bidirectional for this one because I think signals are moving in and out of it essentially. The rest of these choices are just graphical. I'm not really worried about them. You can always adjust them later if you wanted to, so click OK. And then left click to place this anywhere on the sheet. We can and will move this around later anyway. And you can see that I made it a bidirectional electrical type as well. Ta-da! So now I suggest that you pause the video here and add the other 5 pins: ground, feedback, enable, V out, and V in. Great, so here are the 6 pins. You can see that I set the ground and V in to power inputs, V out to power out, and the feedback and enable signals to inputs because signals are coming into them rather than out of them. Does that really matter? Probably not. And it actually, frankly, could cause me more headaches than it's worth later. It is interesting that all of the built-ins, as I mentioned, were all passives instead of actual parts. I'm pretty certain that's a hangover from, or holdover, excuse me, from previous iterations of KiCAD where it was just like became a huge pain. Nowadays, it's just a warning, so less big of a deal. Anyway, so yeah, hopefully yours looks something like this. If you left them as unspecified or bidirectional, totally fine. It does not need to match mine in any way. Next, we're going to make a box to identify the symbol's outline. It's important to do this in order to make sure that you tell whoever is using this and whoever is reading the schematic that all of these pins are all connected together, are all related in some way. So let's go ahead and use the rectangle tool, make it big enough that all 6 pins can sit nicely around it. Mine looks like this. There's an algorithm by which I generated it on the left, but I basically ignored it, and I generated this and then made another box that's completely a different size. So frankly, it's not a big deal. Boxes are always good places to start, even if, and you can easily adjust them by just clicking the corner of any box, hitting escape to exit box mode, but clicking a corner or the side of any box and just dragging. Really nice, really easy to do. As long as all the pins fit, that's really the important thing, because again, we have nets, and nets will mean that the pin placement isn't super important. Visually, it can be useful, but like electrically, it doesn't really make a difference. One important fact that I've mentioned before, and I'll mention again, is that while the graphics can be aligned to actually any grid spacing you like, or no grid at all, the pins have to be on this 50 mil 1.27 millimeter grid, not 0.127 millimeter. That's a typo. Or they will not be able to connect to the wires. If you make this mistake, you can always come back into the symbol editor and fix it. But try not to make this mistake. It's annoying. So once you've made your box and adjusted it, we're going to move all of the pins on that 50 mil 1.27 millimeter grid around this nice little box outline such that the line of the pin, that red line, touches the edge of the box with the pin name on the inside and the number on the outside. Should look something like this for pin 1. You can just move it by clicking and dragging, or clicking and hitting M, or right-clicking and going to move. All of those are equally valid. Once you've placed the first one, you can go ahead and place all of the other pins around the box. You can also, R will rotate. And again, all of this can be adjusted later, even after you have it in the schematic. You can always come back in here because this is in our own custom library, so we can just adjust it and edit it as we want to. In fact, actually, we can edit built-in symbols as well. It'll just be like a schematic only edit. Yours could look like this, in which you're organized by pin number. You could also organize it by pin function. Sometimes that's a little bit more useful. It's totally fine, nothing wrong with that. This is also totally acceptable, although a little bit less common. Mine is going to be more like this, in which I totally changed it up. I actually based this on what the recommended circuit, typical application circuit looked like, as well as kind of conceptualizing how I wanted this circuit to look. Functionally, it's totally identical, but maybe it'll look a little bit cleaner later. I don't know, whatever. I can always adjust it later as well, so it's not that critical to get it right this time. Additionally, remember when we learn about nets, you'll understand, or if you haven't learned about nets already, you should go to video 5C, I think, and you'll understand why it doesn't really matter how the symbol is laid out right now, because the pins can connect anywhere over a net anyway, so it doesn't matter. As long as you have all 6 pins around the edge of your box or outline, part outline, that is the important thing, and everything else doesn't really matter. Great. So let's move the reference designator, that U, from the left-hand middle there, somewhere where it won't be, obstructed by everything else. Usually the corner, the outsides of the corner are where it goes, but doesn't have to be. The middle is also okay, although less traditional. The reference number will appear slightly to the right of the U, just so you keep that in mind. I moved mine to the top right, so that's great. Next, we're going to change the anchor point. That's where the symbol will kind of be attached or anchored to your mouse. Usually the middle or the corner is a good choice. You can use this icon on the right, and then just click left click wherever you want to set the anchor. And then lastly, we need to add the part number, or part number as a value. So double click anywhere outside the part on the canvas, or go to File, Symbol Properties. And as always, these windows have a lot more options than we need, and they have a lot of flexibility, but we don't need any of this right now. All we're going to do is add the part number, that's RT4526GJ6, to the value field's value. That's one below the highlighted field right now. You could also add a footprint here if you knew exactly it had one footprint, and that footprint would be the default footprint. It could be changed later as well in the specific symbol, like for whatever reason, both in this kind of master symbol as well as each individual instance could be changed. So not that critical. You can see that I added it in there. Just click OK once you're done in the lower right. And now we're going to move the part's value somewhere where it can be read, either in the corner or on the edge or in the middle, something like that. I move mine in the middle, and congratulations, you have a completed symbol. If it turns out not to fit, whatever reason, or you want to change it for some other reason, just come back into the symbol editor and edit away, and then save. Do not forget to do that. If you're in a schematic or doing this through a schematic, you can add it directly to the schematic with this little icon here, or you can choose to close the window to not do that. Lastly, if the symbol is in a schematic and you've edited it, make sure to go back into the symbol's properties within the schematic, that is, right click and go to properties and click the update symbol after any adjustments so that it actually updates properly. Sometimes it gets stuck and doesn't actually update that. Cool. So this is the last symbol that we actually added to our custom library, if you remember correctly. So we can actually go ahead and just save the library and then close this window. Now, whenever you add symbols to your schematic, just use the symbols in this library rather than the built-in libraries. Nice and easy. Do not forget to save. And yeah, we can just close this and head back to the main project window. So back at the main project window, under the Preferences menu at the top, go to Manage Symbol Libraries. There's a very similar option for managing footprint libraries, and the windows are nearly identical. The window that opens is where you can manage which libraries are active and visible. I'm not sure if a library can actually be deactivated and still visible, but it can definitely be active and invisible. That's definitely allowed. At the top, there are 2 tabs. Let you switch between library scopes. Let's switch to the project-specific library. Conveniently, the library we just made is automatically added as both visible and active, which is excellent, which means we can add the symbols from within it without doing anything else. Job well done. If you wanted to add additional libraries that would just maintain the project level scope only, click the plus icon here to find them. You could grab libraries from other projects, for instance, or all kinds of other stuff. sort of. Anyway, I'm going to spend the last few minutes demonstrating the SnapMagic's InstaBuild symbol generator. It's a browser-based, computer vision-based symbol generator. It's only available for symbols that specifically offer it on their parts page on the SnapMagic website, as I mentioned. If the InstaBuild feature is available, the link from the part page will lead you here. This is like a 3-pin package. This would be the easiest thing to do a symbol for on your own, but it's just an example. So we're going to go ahead and hit Get Started. Pretty easy to walk through, to use, frankly, but you know, walkthroughs. So on the left, it'll automatically bring up a data sheet for your part, which is nice. You're gonna kind of scroll through the pages and locate the pin table in the data sheet, which has your pin number and your name. And then you're gonna left click and drag within the data sheet to highlight it, like so. You want to highlight the pin number and name. You don't need to highlight the functions or the column headers like I did in here. Oops. Once you've highlighted the pin numbers and names, click the Extract Pin Map from Table button, highlighted here. The pin tables will then be generated on the right. Nice and easy. Notice that I highlighted the column headers, which then showed up in the table. Just click X to remove that row. Voila! Now just click the Generate Part, and the symbol will be generated. Don't expect anything fancy here. Looks like that, and now the symbol is ready to be downloaded and imported into KiCAD. Just click the Download Symbol and Footprint button on the left there in orange. As you can probably tell, this is much more useful for devices with many pins rather than just 3. Like most generators, the more kind of things it generates, the easier your life is. And again, I mentioned this before, but you can just import it through the symbol editor window by right-clicking on the library and on the Import Symbol button and locating the KiCAD sim file. Adjust and edit as needed. Double check the pins and whatever that you need, and then save. And that ends part 6 of this video series, in which we covered creating and filling our own project-specific symbol library. A PDF of this video is available as well, linked in the description and hosted on the Hive's Wiki. In the next video of the series, part 7a, we will cover creating a footprint library and populating it with globally available models from KiCAD's built-in libraries. See you then.